Hello students. In this video, let us discuss about the 2024 solved paper of rotational motion of Eapcet Telangana. So the first question asked on 9th May, shift 1 is a solid sphere rolls without slipping from the top of the inclined plane of height 28 meter and angle of inclination 30. The velocity of sphere he is asking to find. So G he is saying to take as 10 meter per second square. Now what he said, a particular inclined plane of 28 meter height is there. From the top of this plane, a solid sphere is rolling down without slipping. Now at last it reaches the bottom. So we have to find what is the velocity when it reaches the bottom. This sphere, when it is at the top, it has potential energy. While rolling down, it gains kinetic energy. By law of conservation of energy, potential energy will be equal to the kinetic energy. Potential energy is mgh. Kinetic energy, this is rolling sphere. So for rolling sphere, we have rotational kinetic energy half I omega square as well as translational kinetic energy half mv square. So potential energy mgh is equal to half mv square plus half I omega square. Now for sphere, the moment of inertia is 2 by 5 mr square if we substitute, and v equal to r omega, omega equal to v by r. If we substitute these both values and simplify, we get the value of half mv square plus half I omega square as 7 by 10 mv square. Strikes off from this v square equal to 10 by 7 gh, where g is 10, h is 28. Now simplifying, we get 20 meters per second as answer. Right? Now let us go for the next question asked on 9th May, shift 1 itself only. The four identical particles 1, 2, 3, 4 as shown in the diagram, each of mass m, all are having same mass is not changing, are kept on four corners of the square. Right? Now if one of the particle is removed, okay, in these four particles, if one of the particle is removed, then he is asking to find the shift in position of center of mass. Right? Now as per given problem, we placed four particles, assume as A, B, C, D on four corners of the square. Right? The mass of them is same, m. First let us write down xy coordinates. Now the coordinate related to A. Now see, this is x-axis, this is y-axis. Now point A is on y-axis. So now related to y-axis, the value on x-axis will be 0. We know that. So the coordinates of A becomes 0, comma A. It is assume that these are the distances A. Right? Now similarly the coordinates of D. D, it is nothing but it is at origin position. So 0, comma 0. C, now it is on x-axis, you see. So A, comma 0. And B, it is A distance from a y-axis, A distance from x-axis. So A, comma A. So A coordinates are 0, comma A, B, A, comma A, C, A, comma C, D, 0, comma 0. Right? Now center of mass formula, m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. No, following that formula, m here mass is same, so I am writing m for all. mxa plus mxb plus mxc plus mxd equal to m plus m plus m plus m. So m, if we take common, it strikes off. So xa plus xb plus xc plus xd by 4. Now xa. Now these are x coordinates, these are y coordinates. Now let us see the xa, 0, xb, a, xc, a, xd, 0, divided by 4. A plus a, 2a by 4, 2 2s are 4, so a by 2 we will get. xcm. Now similarly ycm we have to find out now. mya plus myb plus myc plus myd by 4m. Now ya, here you see a, yb a, yc 0, yd 0. Now here we substituted a plus 0 plus 0 by 4. You will get 2a by 4, that is a by 2. Now what he asked, if he remove one particle, then what will be the new center of mass he is asking. Now let us remove from this A, B, C, D. Let us remove B. Okay. Here, if we remove B, what we will get? A, C, D. Right. If I remove this B, what you will get? A, C and D. That only I drawed here. Right. A, C, D. Now here distances we denoted with A. So now first the new center of mass x dash cm. M xa plus M xc plus M xt by M plus M plus M. We removed B. Now here I am writing the coordinates. A is 0 comma A. B we removed. C A comma 0. And D 0 comma 0. So what you will get? MM strikes of XA. Y coordinate no A plus 0 plus 0. A by 3. Similarly Y coordinates. Sorry, X coordinates 0 plus A plus 0. That is A by 3. Now let us write the center of mass of Y coordinate. Now Y you see A plus 0 plus 0 by 3. We will get A by 3. Now shift in position. Shift in position. Here x dash cm. How I am writing means shift in position x dash cm minus xcm plus y dash cm minus ycm. X dash cm is a by 3 and xcm a by 2. Y dash cm is a by 3. Now ycm we got a by 2. Now substituting these values, right? So a by 3 minus a by 2 whole square plus a by 3 minus a by 2 whole square. Now this value is minus a by 6 whole square plus minus a by 6 whole square under root. So it becomes a square by 36 plus a square by 36. So this becomes under root 2a square by 36. That is equal to root 2a by 6. 6 you can write it as 3 into 2. Now root 2 if it cancels, a by 3 root 2. We will get the new position or shift in a position of center of mass. Right? Now next, let us go for the next question asked on 9th May, shift 2. A thin uniform wire of mass m, linear mass density, right? Linear mass density rho is bent in form of circular loop, right? In such a way. Mass is m, linear mass density is rho. Now the moment of inertia of loop about its diameter he is saying, right? So mass of wire what he said? M. Linear density, mass density rho. Let us assume that the length of wire is L. Radius of this circular loop is R, right? Now, or radius of wire is R. Now, rho, density means what? Now here, rho will be equal to mass by length. Okay? Now here, mass will be equal to rho into length. Right? So, as this is a circular, actually density means what? Mass by volume. Here, volume is equal to length L only. So, now, next, this is circular loop, no? Circumference 2 pi r. That is equal to nothing but equivalent to length. From this r equal to L by 2 pi. Put it as equation 1 and equation 2. The moment of inertia around the circular loop. Circular loop, no? Half mr square. Okay. Now, I equal to half. What is m? From this equation 1, rho L. And what is r? L by 2 pi whole square. If we simplify rho L into L square, L cube by 4 pi square. Now, I equal to 2 4s are 8, 1 by 8 pi square rho L cube. Now, from parallel axis theorem, I diameter equal to I center of mass plus mr square. So I center of mass, where we got L cube rho by 8 pi square, this one, plus L cube rho by 4 pi square. Okay, L cube rho by 4 pi square. Okay, now this, if we simplify, we will get 3 L cube rho by 8 pi square. Okay, here you see mr square 2i. We are substituting this. Now it cancels and we will get L cube rho by, you understood? Here mr square. Mr square means 2i. So how we will write 2? What is I? This value, no. 2 4s are. So rho L cube by 4 pi square, like that we wrote. Now this already we find it here. If we simplify, you will get 3 by 8 m cube by rho square pi square. Okay. Now next, 3 particles, some A, B, C of masses, some m, 2m, 3m are moving towards north, south, east. Okay. Their velocity is 6, 12, 8 meter per second. Then velocity of center of mass of system of particles he is asking. One particle, mass m, with velocity 6 meter per second, moving towards north. Other particle with mass 2m, moving towards south with velocity 12 meter per second. Other particle, mass 3m, with velocity 8 meter per second, moving towards east, he mentioned. That we drawed. Now, let us write the velocity of center of mass. So, mass into, this is plus y direction, minus y, plus x, minus x. So, 6j can I write? Y direction, no? Plus. Next, this 2m into, what is the velocity? Minus 12j I will write, because negative y direction, south direction, plus this one, positive x direction, 3m, 8 I will write, x no, I will write. Now if we simplify, 6mj minus 24mj plus 8 3s are 24, 24 mi. 6 minus 24 minus 18, right? So here minus 18 mj, what we will get? Minus 18 mj plus 24 mi by 6m. So m here common, cancels out. So 6, if I take the common, what happens? 6 3s are 18 minus 3j plus 6 4s are 24. 6 again cancels. How we will take? If I take 6 common, minus 3j plus 4i by 6. 6 cancels. Also cancels. So minus 3ij plus 4i. Magnitude under root 3 square plus 4 square, that is equal to under root 25. We will get 5 meter per second. Right? Now this is about 4th question. Now 5th question. This T alphabet he took. Okay. An alphabet T made of 2 similar thin uniform plates. This. Each of length and width. Length is L, width is A. Placed on horizontal surface. If now alphabet is reversed in such a way. Now it is T, no? Again he is reversing the alphabet in such a way. Then he is asking to find the shift of position of center of mass. Right? Now first, the direct position T, width A, length L. So this length from horizontal surface also L. So let us assume here is the center of mass. From center of mass to here, the length becomes L by 2. This is total L, no? So it becomes L by 2. So YCM will be M1 Y1 plus M2 Y2 by M1 plus M2, no? So M1 and M2. So M1 is equal to M2 is equal to M. Right? Now here M Y1 L by 2. plus m y2 up to here L plus a by 2. So from here we are considering, right, L plus a by 2. Okay. So substituting m up to here L by 2 plus total length L. So here up to here you see, now up to here length L, this will be a by 2 and this is L plus a by 2 by m1 plus m2, m plus m 2m strikes off. Here what you will get, L by 2 plus L, 3L by 2 plus a by 2 by 2. Now here 3L plus a, now 2 goes into the denominator, 2 into 2 4, right? Now next invert it. Now like this T. Here is the center of mass 100%. When we invert it shifts, no? If total length is L, now here to here A, now this becomes a by 2. Okay. Now here to here L by 2. Okay. Now total length L. This be M2, this be M1. M1 Y1 dash plus M2 Y2 dash by M1 plus M2. M1 and M2 we are substituting as M. Now first Y1 dash, here to here, Y coordinate, A by 2 plus M into. Now next, here to here A, okay, and here to here L by 2, A plus L by 2 by M plus M. Now simplify, you will get 3A plus L by 4. Now difference in shift he asked to know. Here Y centimeter is 3L. What is Y centimeter? 3L plus A by 4. So you substitute 3L plus A by 4. Y dash is 3A plus L by 4. If you simplify, you will get 1 by 2 L minus A. Right? Now the sixth question asked on a shift 1/10 May. Now a solid sphere and disc. This is solid sphere. This is disc. Solid sphere mass m. They both are having same mass m and radius r are kept that their curved surfaces you see in the diagram are in contact to each other and their center lies along the same horizontal, right? Along their centers, this lies along the same horizontal line. The moment of inertia of two-body system about an axis, he is asking to find the moment of inertia of a two-body system passing through the point to the contact and perpendicular to the plane of disc, he said. So, moment of inertia of sphere, we know 2 by 5 mr square. From parallel axis theorem, moment of inertia for sphere, S for sphere, I plus mr square. I 2 by 5 mr square plus mr square. If we simplify, 7 by 5 mr square. Put it as equation 1. Now, moment of inertia of disc, mr square by 2. Parallel axis theorem, D for disc, I plus mr square. I is mr square by 2 plus mr square. We will get 3 mr square by 2. Now, total moment of inertia due to sphere plus moment of inertia due to disc. You substitute these two values of equation 1 and equation 2. You will get 29 mr square by 10. Right? Now, next question, 7th question. A circular plate of radius r is removed from uniform circular plate P of radius 4r to form a hole. If distance between the center of hole and the center of plate is 2r, then the distance of mass of the remaining portion from the center of plate. So let us draw the diagram now. This is the plate. From that, a r radius part is removed. Now here a hole is created. Now the radius of this large sphere is 2r. Now, 4r. Now this is sphere r. Now here to here distance 2r. Now center of mass position x1, here you assume as x2. Now here we are using the formula for center of mass of area, a1 x1 minus a2 x2 by a1 a2. Now a1 area of plate, a2 cut portion, x1 0, x2 2r. So a1 becomes pi r square, no? A means pi r square. So pi, r is here 4r. The radius of large sphere is 4r. 4r whole square. A2 equal to small sphere radius r, pi r square. Now substitute a1, x1. x1 is 0, no? x1 lies on this y-axis. So 0, 0 into something 0. So I wrote 0 minus. Now next what we are having? A2. x2. What is A2? Pi r square. Into what is x2? Here to here distance, it is 2r. Right? Now divided by a1 minus a2. Pi 4r whole square minus pi r square. So if we simplify, you will get minus 2r by 15. We are considering only magnitude 2r by 15. Now next, a hollow cylinder and solid cylinder. Both are at rest at the top of inclined plane. Now without slipping, they are rolling down. If time taken by the hollow cylinder to reach the bottom of inclined plane is 2 seconds, the time taken by solid sphere to reach the bottom of inclined sphere. What he said, on inclined surface, he kept two bodies, one hollow cylinder and one solid cylinder. He released them. Now both are rolling down without slipping. Now if the time taken by hollow cylinder, hollow and this what we will say solid. You assume this as solid cylinder, this as hollow. Now hollow cylinder took the time of 2 seconds to reach to the ground. Means up to here, to the bottom. Right? To the bottom. Now the time taken by the solid sphere to reach to the bottom, he is saying. Formula is T equal to under root 2s by g sin theta beta, where beta value is 1 by 1 plus k square by r square. Right? Now next, here r is the radius, k is the radius of gyration. T from this equation, T proportional to 1 by root beta. So now T1 is the time taken by the hollow sphere to reach the bottom, T2 by solid sphere. Now T1 by T2 following this under root beta 2 by beta 1. Now beta value for hollow cylinder 1 by 1 plus k square by r square. For hollow sphere, k square by r square value will be 1. So 1 by 1 plus 1 equal to 1 by 2. Now for solid sphere, k square by r square value, k2 equal to r by root 2. So from this k square, k2 square by r2 square is equal to 1 by 2. So here we substituted 1 by 2. 1 by 1 plus 1 by 2, 2 by 3. Now put this in the equation here. T1, 2 seconds he said for hollow sphere, 2 seconds he said. T2 we have to find out. Beta 2, 2 by 3, beta 1, 1 by 2. If we simplify, we will get 1.732 seconds the solid sphere takes to reach the bottom. Now next, the 9th question. A meter scale is balanced on a knife edge like this. Okay, a meter scale. Meter scale means 100 centimeter. It balances at 50 centimeter. Remember that. Balances on knife edge. So meter scale means 100 centimeter. It balances at its center 50 centimeter. Now here, what he did means, here at this particular position, marked 10 centimeter. Placed two coins like this, one over other, each of 9 grams, each of 9 grams. Okay, the scale is found to balanced at 35. Means if it is 20 centimeter, from here to here, it must be 25 only, no. Now means 35. At this particular point, the scale is balanced. Now he is asking to find the mass of the meter scale. Now for that, here I said no. Mass of each coin 9 means total mass 18 grams. Meter scale 100 centimeter. balancing point, he said 35 in the problem. And he kept these two coins at 10 centimeter mark, he said. Now the distance from new balance point 35 minus 10, this becomes 25 only, no? Okay, this becomes 25. Torque due to coins, F dot R. F means mg, R. M is 18, the mass of two coins, into G into 25 centimeter new balance point. Okay, new balance point to the coins. Now next, the center of mass of meter scale balances at 50 centimeter. Meter scale means 100 centimeter. It balances at its center 50 centimeter. So 50 minus 35 you do. Distance from new balance meter, 25 plus 10, 35. So 50 minus 35. How much you will get? 15 centimeter. Here up to here you assume. Now center of a meter scale becomes mass into m into g into this 15. Right? This formula only, mgr. R is here 15. M into G. Now equate. Now here, for the scale to be balanced, the torque must be conserved. So equation 1 must be balanced by equation 2. 18 G25 equal to mg15. So Gg strikes of m, you will get 30 grams. Now the last question of 2024 is, a body of mass m, radius r, rolling horizontally with velocity v, rolls up an inclined plane. So in such a way, they are rolling up to the height v square by g. Now, what he is asking? He is asking to find what kind of body is this. Okay, now let us find out. Moment of inertia of body, assume as I. Initial kinetic energy, while rolling, it gains kinetic energy. So rolling body has one rotational kinetic energy half I omega square, translational kinetic energy half mv square. Potential energy is mgh. When it reaches the top, it will gain potential energy. So that is kinetic energy converts into potential energy. Now h in problem he gave as v square by g. Right? When body roll up, then kinetic energy is converted into potential energy, no, at the top. So kinetic energy is equal to potential energy. So kinetic energy half I omega square plus half mv square equal to potential energy. Here what it happens? Potential energy mgh. H is v square by g. Gg cancels, mv square becomes potential energy. Now here what happens? Half I omega square equal to this, you send to this side. What happens? mv square minus half mv square is nothing but half mv square itself only. So now omega I send to this side. Half cancels. So I equal to mv square by omega square. V means what? R omega. Right? So m r omega whole square by omega square. So now here what we are getting? Omega square strikes off, mr square remains. So mr square is the moment of inertia of ring. The body here is nothing but ring. So these are the 10 questions asked in 2024 related to rotational motion. So if you like my video, share it, subscribe it. So keep watching my videos. So yours, Reshma Physics. Thank you for watching. Stay with my channel to receive more videos regarding the solved paper of Eapcet Telangana.